Hello everyone. Today's first lesson is on metals and non-metals. So if you can start by getting the date, title, keywords down, and then the do now task. This video can be paused while you get that done. So I'm now going to move on to the answers to our do now task. So for sodium hydroxide, we have one sodium, one oxygen and one hydrogen in our chemical formula. So you should have simply added the masses of each of those together, which gives you 40. And for sodium oxide, the formula tells us that we've got two sodiums. So we multiply the mass of sodium by 2, add that to the mass of oxygen, and we get an answer of 62. Okay, so today you're going to be looking at the physical properties of metals and non-metals. In other words, the similarities and differences between what they're like. That's what we mean by properties, just kind of means what are they like. So by the end of the lesson, you'll be able to know where metals and non-metals are on the periodic table. And we've got various keywords that you'll be learning to use when we describe the properties. Okay, here's a periodic table. Finding metals on the periodic table is pretty simple, actually. The middle and the left-hand side of the periodic table are metals, so they're the ones shown in red. Hydrogen in the top left is the exception there. That is a non-metal, and actually sometimes hydrogen and helium are shown at the top of the periodic table. You'll see different versions differ very slightly. On the far right, we have the non-metals, and generally speaking, this black staircase line you can see over here is used to divide metals from non-metals on the periodic table. But there are a few elements known as metalloids. So metalloids are elements which have some properties that make them very similar to metals and some properties that make them very like non-metals. So those are the ones shown in yellow. But generally speaking, you need to remember that the staircase starts between boron and aluminium, and that staircase is what divides metals from non-metals. Okay, so we're going to watch a video now about the properties of metals and non-metals. You need to be paying attention to the keywords and definitions because you're going to be completing a worksheet on that straight afterwards. Sorry, I forgot to queue up the video before I started. We'll do that quickly now. That means you might get the adverts.
You, this screen, your dinner, the planet, and everything in the universe are all made out of the same things, atoms. What are they? Press start to find out. Here is a single atom. Everything you see around you is made from atoms like this. Trillions and trillions of them. Atoms are incredibly small, and I mean very, very, very small. Drag the slider to zoom out to something bigger. Yes, those atoms were part of this beautiful beach ball. Oh, atoms are so small, there are about 1 million of them on the point of this needle. Yes, 1 million. There are over 100 different types of atom, and each type is called an element, like iron, oxygen, and carbon. Choose an atom to look closer. This is an iron atom. That's one of the elements. A piece of pure iron is made from trillions of iron atoms, all exactly identical to each other. Here are the atoms of some other elements. Every element has a name. This one's copper. Each element also has a symbol, but the letters in the symbol don't always match the name of the element. Very helpful. Anyway, scientists have grouped the elements together into the periodic table to help make sense of it all. Elements that are similar to each other are found in things called groups. Look at this periodic table and select the part you think is a group. Nope, sorry. Groups are the vertical columns of the table. The horizontal rows are called periods, as in periodic table. Get it? Another thing about the periodic table is that you can divide it between the metals, the big clump on the left, and the non-metals, this little bunch on the right. Metals and non-metals don't have a lot in common. You see, for a start, the metals are bright, exciting looking and shining. The non-metals are a bit dull. Want to see what else is different about them? Click and hold your mouse down to see what happens. Non-metals float, generally speaking, but metals don't, generally speaking. And that would be why we fill balloons with gas, not metal. Genius! Lots of non-metals are gases at room temperature, like nitrogen, chlorine, and hydrogen. Oh, be careful. I forgot about bromine. It's the only one that's liquid at room temperature. Okay, moving on. You need to connect the battery with the bulb. Give it a go. It's a dud. Non-metals just don't conduct electricity. But that's useful. We can use them to insulate wiring and stuff like that. Now the other one. Now you know why we use metals in electric wiring. Metals conduct electricity. Here's a question. What about carbon? It's a non-metal element and can come in many forms. Yes, graphite, the stuff we use in pencil lead, and diamond, the stuff we use in bling, are both made from carbon. Diamond is a hard nut. It's the hardest natural substance known. But it's also kind of brittle. Graphite, on the other hand, is soft. But the interesting thing about graphite is that it can conduct electricity. And it's not even a metal. Pretty cool. Let's leave carbon now and get back to more differences between metals and non-metals. Move the flame to apply some heat. The non-metal is really slow to heat up and cool down. Look at that metal go. Metals heat quickly, glow, and also cool quickly. I'd like to introduce you to mercury. Mercury is a metal, but it's also a liquid at room temperature. Watch it rise as it heats up. That is how a mercury thermometer works. Cool. Or hot. Listen. Give these to a tap and listen to the sounds they make. Now the other one. Did you hear the difference? The metal makes a sort of metallic ringing sound. The metal is called sonorous for that reason, but the non-metal isn't. What next? Ah, yes. Can you crush these two lumps of stuff, please? The metal is just bending and flexing. That's what's known as malleable. Non-metals are not malleable. Only 3 elements are attracted to magnets, and they are all metals: iron, cobalt, and nickel. Nothing else will stick. Have a go and see. Magnets are a nifty way to separate iron from other stuff. Then you can recycle it. Time for an atomic recap. So you, me, the screen you're watching, your clothes, your home, are all made up of atoms. There are many types of atoms, called elements, like iron, sodium, carbon, and oxygen. They are listed in the periodic table. Got that? Good. You've seen that most elements are metals and a small amount are non-metals. They have opposite physical properties. Look through this table for a quick reminder of which does what.
Okay. I'm sorry if you can hear my laptop buzzing away in the background, but the fan keeps kicking in. There's not a lot I can do about that. Right, okay, so you have a worksheet to have a go at now. There are instructions at the top. First of all, you're going to match keywords and definitions, and then you've got then you're going to write those down and draw little pictures to help you remember what they mean. So spend a few minutes matching the keywords to the definitions. The video can be paused now, and then press play when you're ready to just check through those definitions, and then after that you can finish off the worksheet. So pause to continue that now. Okay, and if you're ready to check you've matched the keywords and definitions correctly, I'm going to put those answers up now. So you should have matched malleable to can be hammered into shape, sonorous, makes a ringing sound when it is hit or struck, conductor, heat and or electrical energy are easily passed through, insulator, right to the bottom, heat or electrical energy can't easily pass through, brittle, breaks easily, flexible, bendy, dull, non-metals are usually like this even when polished, and shiny, all the way to the top, metals are like this when they are polished. If you didn't get all of that, you could pause the video now and just check your answers. I'm going to move us on. Okay, quick true or false to check your understanding. You can jot these down or just think them through, or you might want to do a thumbs up, thumbs down for whoever is with you today. So we'll go through them one by one. Metals are shiny, true or false? That's true. Metals are poor conductors. That's false. Non-metals are malleable. That's false. Ductile means can be bent into shape. That's also false. Ductile means can be stretched into wires. Copper is used to make wires. That's true. Copper's a really good conductor. All metals are magnetic. That's false. Just iron, cobalt and nickel are the magnetic metals. Okay. Your next task today, which will take probably 10 to 15 minutes, is the properties worksheet. So the first example I've done for you, you've got pictures on the left hand side and a description of what you're looking at. You need to tell me what material you think the object is made of. So our plug sockets are made of plastic. And then what useful properties plastic has that makes it suitable for a plug socket. So we use plastic because it's a good insulator, so it stops us getting an electrical shock. If we made plug sockets out of metal, then we would get an electrical shock. So this is your next task. So I would think to do that properly will take you at least 10 minutes. So pause the video now and then I'll go through the answers with you. Okay, let's go through what I hope you've got on your sheet. So copper wire found inside electrical wiring. It's obviously made of copper, which is a metal, and copper's used for wires because it's a good conductor of electricity. It's also ductile because it's metal, which means it can be stretched out into wires. Wooden spoons are made of wood, which is a non-metal, and that's the useful property is that it's a poor conductor, so the wooden spoon doesn't heat up when you stir hot things with it. Aluminium metal for an aeroplane, obviously made of aluminium. Aluminium is light and it's malleable, so they're both really important properties for making an aeroplane. Bells will be made of some sort of metal, and the useful property for a bell is that they are sonorous and malleable. Plastic bags are obviously made of plastic, so plastic is really flexible. Not all non-metals are, but plastic is flexible. It's also waterproof. Maybe you got that. Wool jumpers made from wool, which is a non-metal, and wool is a really good insulator, so that's why it keeps us warm. You may also have said that wool is a flexible non-metal, so that obviously is useful for its changed shape. Okay, that's your last activity. If there's any time left and you've finished, then you need to spend some time learning those keywords and definitions really, really well. And you could perhaps test the person next to you, or maybe have a look around the room, look at some other objects, see what they're made of, and think about why those objects are made of those materials and what their useful properties are. That's all for now.